class, tree. Get a little bit more excited, tree. Okay. All right, Christian, you good? Yeah, something like this. Okay, so this is officially it's called L'Hopital's rule, but unofficially it is L Hospital's rule, because that's what it looks like. L Hospital. Are you going to the L Hospital? That's kind of Spanish, right? No.
Oh.
L Hospital. Okay, so anyway, all right, yeah. All right, I would say it's kind of racist, but it's really not, because it's just making fun of the language, not having to do anything to do with a specific race. Because most of South America speaks Spanish in some way, shape, or form. Anyway, all right, limit. X goes to infinity. ln x. Now, so as we plug that in, we try it out to see. So now, ln, if you remember the graph of ln, it starts at a vertical asymptote at 0. It has a vertical asymptote at 0. It goes up and it crosses the x-axis at 1. Because ln 1 is going to be 0. No. Yeah, ln 1 is 0. And then from there, it just curves up. Okay, and it keeps going up gradually. Okay, so as I go to infinity, this also goes to infinity. And plug that in. Plug in infinity to x, what do you get? Infinity, that's what we get. So we get infinity there. Now, that satisfies the rule for, okay, you ready? What's the word? Say it again. Indeterminate. Okay. How do you say it? Yeah. See? Now, let's go ahead and take the derivative. What is the derivative of ln x? It's going to be what? 1 over x. One over x. You got that rule written down? Because that's usually one of the crazy ones that most people forget. Write it down!
What rule?
What's the derivative of ln x?
1 over x.
Okay. Tree, do you agree with that one? You ever watch Digimon? You know, like that one guy that has the headphones on all the time? That. How dare you? You only got to watch the first 2 seasons. Because after that, they just try to milk it. Oh, okay.
It's too much like Pokemon, but it's not Pokemon.
What's the derivative of x? Now can I do a limit of this? Can I plug this in? Okay, so 1 divided by infinity. So think of it this way. Let's go, what's 1 divided by 2? 0.5, right? Right? 0.5, okay. And going to infinity, that's positive infinity, so I'm going bigger numbers, right? So what's 1 over 4? 0.25. Okay, now what's 1 over 10? 0.1. What's happening as I'm going to infinity?
You're getting
Closer to 0. There we go. So mentally, if you think about that and start putting those in, you can see, okay, if it's 1 divided by infinity, so I'm going to order a pizza later on, okay?
Really?
Yeah, just 1 pizza though. And so what's the good thing about that? You you gotta share it. Okay, I'll share it with you guys. But that one pizza divided by how many students we share it with does matter, right?
Right.
So if I invite a whole bunch of students here, what does that mean?
You're gonna have like almost no pizza.
It's going to get smaller and smaller, right? So as I get closer to infinite number of students, sorry, I came in late. So one pizza divided by infinity students, how much pizza does everyone get? You get 0. You just get a sniff of it. That's it. So this is so there's my ln x, right? So you can see there is a vertical asymptote at 0. At 1, it goes to 0, and then it just keeps gradually going up. So that's where my infinity over infinity is. So, there you go. Okay. Next one. Limit x over e to the x. So if I plug in infinity, what do I get on top? Infinity, right? To infinity. Wow, I just like really aged myself on that one. At a certain point, all my students would respond to that one.
So you're like,
Yeah, thank you. To infinity.
and beyond.
See, there we go. But that was like,
I didn't know it was a reference. I didn't know you were trying to reference that.
oh man, no, seriously. But it should like, yeah. But yeah, I guess I'm just so old. Now you guys don't watch classic. Anyway. All right, so e to the infinity. What's that going to go to? Infinity, right? It's going to just keep going up, isn't it? So we have infinity over infinity. Hey, how you doing?
Good, how are you?
Just so you know, you're being recorded right now. So you are on, not camera, but yeah, I'm recording my lesson because I got some people that decided to not show up, and then yeah, because they think it's their birthday, and then yes, I'm throwing some shade at people that are not here because it's their birthday. Go ahead.
I'm just trying to get some work for a student that has not been here the past couple of days.
Days, weeks, or months?
Days. Maybe a week.
In this class, or a different class?
8th period.
8th period. Oh, okay. So yeah, that's going to be my engineering, which is going to be something a lot different. Can I finish my notes and then come back?
Do you want to just chat me when you're done?
Yeah.
Okay.
There we go. Send me a message reminding me because I'm going to forget.
Okay, thank you.
Anyway, so let's take the derivative. What is the derivative of x? It's 1. What's the derivative of e to the x? And so now can we plug it in? So, right here, what's this one? What's the bottom going to? It's going to infinity again, right? So as I plug that in, that's going to end up with 1 over infinity, which gives me okay, because we divide up that pizza, and every time, so as it's getting bigger and bigger, I'm dividing up that pizza, going down to 0, right? Okay, next one. This one right here, isn't that the same as what we just did? No, it's not. Okay, so again, here. So this one, plug it in, I get infinity over infinity. Take the derivative. What's the derivative of e to the x? Isn't that e to the x? Derivative of x is 1. Now I could plug in infinity. And so, as I'm taking e to the infinity, what is that answer? Infinity. Infinity divided by 1, which is just infinity. My infinity symbols normally aren't that bad, but, pretty bad today. So, there's some rules to go along with this. So, whenever you see these ones here, you could automatically say, hey, guess what? That goes to 0. Same thing goes for that one. Alright. Find a limit using L'Hopital's rules. So, first thing I have to do, I have to check to see what it goes to. And so plug it in. So now, a lot of people still messing this up. So if you're going to screw this up, start by doing this. And so at 0, right here, my coordinate is 1, 0. Tangent at 0. Tangent is sine over cosine. Sine over cosine is 0 divided by 1, which is just 0. Minus sine at 0, which is just 0. Over tangent squared, which is 0 squared, times tangent, which is 0. Anything times 0 is? Thank you. And 0 minus 0? There we go. So, I get 0 over 0, so this gives me the, what's the word? What's the word? Indeterminate. There we go. So now I can take the derivative. Since we have to do the derivative, and this right here, so I take the derivative divided by, of the top, divided by the derivative of the bottom. Not the derivative of the whole thing. Because a lot of people are going to see that and be all, oh, hey, quotient rule. No, derivative of the top, derivative of the bottom. So, the top right here. So the derivative, what's the derivative of tangent? Secant squared x minus derivative of sine, cosine x. Derivative of the bottom, this is a product rule. So it's going to be 2x tangent x. Since it's product, that's a plus. X squared secant squared x. Now we try to plug in zeros. And secant is the reciprocal of cosine. So I take the cosine, whatever I get for cosine, and go 1 divided by that number. So at 0, cosine is 1. So that's going to be 1 over 1 squared, which is still going to be 1, minus cosine at 0 is 1 over, plug in 0, this is going to be 0 times 2 is 0 times tangent, which is also 0, plus 0 times secant squared, which is actually going to be just 1. So on top, I'm going to end up with 1 minus 1, which gives me 0 over 0. So does my first derivative work? No. That gives me the indeterminate again, so that means I need to do it again. So derivative, so let's go through and do another derivative of this. Derivative of the top, what's the derivative of secant squared? I'm going to have 2 secant x, right? 2 secant x times derivative of secant is secant tangent. Secant tangent. Just for the sake of, secant x is the same as saying 1 over cosine x. I'm going to quotient rule here. So derivative, so this is f, this is g, f prime is 0, g prime is going to be negative sine x, and from there I'm going to set up my quotient rule. So f prime times g, which is cosine x, minus g prime, negative sine x, times f, which is 1 over g squared cosine squared x. So this is going to give me a positive sign x over cosine squared x, which I'm going to rewrite that. I'm going to separate it out so we could actually see which item is. So this is going to be sine x over cosine x times 1 over cosine x. These ones right here, you don't have to memorize every time. You could do this. It does take a bit longer to go through and doing your derivatives, quotient rules, and using your sine and cosines only. Sine over cosine is going to give me tangent. Cosine squared is the same as saying secant. Secant, not square. That's secant x. That's why it turns in, and I'm just turning around for secant tangent. Right here. That's why it's secant tangent there. Yes? Okay. So, just so you guys, so when we actually do that, where was that? So, right there. Yeah, so that's the top right there. Minus cosine, derivative of cosine is going to be negative sine. And that's all of the top right there. So this one was the first derivative. This one's the second derivative. Do the bottom, I got another product rule there. I have a product rule here and a product rule here. So the product rule here is going to be 2 tangent x plus 2x secant squared x plus, now I'm over here, I'm on this side here, another product rule, so I get 2x times secant squared plus x squared times 2 secant x times secant tangent. There you go. Now let's start plugging in zeros. We know we have one coordinate on my unit circle. That's it. Add 0. Now I'm going to take the limit as secant, we already did it a couple times, is going to be 1. So it's going to be 2 times 1 times 1 times tangent is 0. Because tangent at 0 is 0. Plus sine at 0 is 0. The bottom is going to be 2 plus 2 times 0 plus 2 times 0 secant, which is 1 squared right there, plus 2 times 0 times 1, which is my secant, plus x squared, which is 0 squared, times 2 times secant, which is 1, times secant, which is 1, times tangent, which is 0. On top, what do we get? We get what? We get 0? Yeah? So we get 0. 0 on top. That's going to be 0 plus 0 plus 0 plus 0. So what does that give me? Indeterminate again, right? So, do we have to do this one or another one? I'm just going to double check real quick. Or did I make a mistake? Levi, did I make a mistake? I love math, but I really don't want to do this many times. Ah, crap. They factored. They factored on this one. Right here.
Will they always factor like this out for nothing? Or...
Yeah, I guess you could factor out a nope. Oh, no, they factored here. The 1 minus 1 minus cosine x over x squared. Holy crap. I totally missed that one. Wow, that one sucks. Tan x minus sine x. Alright, they factored it from here. And so they just changed everything into sine and cosine. That's a sine x, just so you know. My board doesn't like it. and multiply everything by the common denominator, which is going to be cosine. So as that distributes, right there, the cosines will cancel. So I'm left with sine x minus sine over cosine, sine times cosine. And that's going to cancel out a cosine, so I get x squared times sine x. Now the top both has a sine x, 1 minus cosine x, and I can factor out the sine x there. So by removing that right there, that's going to make the whole math a whole lot easier. By factoring all that, we removed a factor of the sines, so I can plug this in at 0. 1 minus 1 is still going to give me 0. X squared, 0. Now if I do the derivative, derivative of negative cosine is going to be positive sine x over 2 x plug it in, 0 over 0, and then do the next derivative, which is going to be cosine x over 2. So this is my first derivative. This is my second derivative. I can plug this in at 0. I get 1. All that work just to get to there. Now, could we put it in the calculator to check to see if our answer was right? Yeah. So how would I do that? What are we looking for here? The limit. So what is the limit? What is the definition of a limit? There you go. Left and right both go to the same number, right? At a certain point. That's the definition of a limit. Let's see what the calculator says about my definition of limit. Sine, tan minus sine. Did I write it correctly? Hopefully, Christian? Okay. Hit enter. And so my whole thing is I'm actually trying to see what the limit is. What is it going to be when it goes to 0? So, menu, analyze graph, and let's go, no, trace graph. Trace graph, 1, there you go. Now, the reason why I'm using the limit of this, because right here at this point is undefined. So I can't just plug it in, I get undefined. So, go slightly over a little bit, and I could actually type in my negative 0.009. No, 1. There you go. So I can get really close to that number using my calculator, and I can see what the answer is supposed to be, the 0.5. So, yeah. Ugh. There you go. Let's try this one, doing the same by plugging it in to see what it comes out without actually doing too much. Because can I take the limit ln0? Isn't that undefined? So I can only take that one from the right, can't I? Because we graphed it, so we say that there is a vertical asymptote, okay, as it's going to, so it's going down, it's going to negative infinity. And so as it's approaching 0 from the right hand side, goes to negative infinity. Now cotangent, what is cotangent? Cotangent is cosine over sine, right? So cosine is a wave, isn't it? And divided by sine, so that one right there is going to be kind of weird. So at 0, cosine at 0 is 1, right? And sine at 0 is 0, but it's not at 0, it's approaching 0. So what is that going to be if it's going to be like that? This is also going to be, is it going to negative infinity or positive infinity? So I'm getting close to 0. So it's going to infinity here. So that's another one where it's going to be infinity or over the negative infinity. And then take the derivatives. What's the derivative of cotangent? Can't remember those ones? It's cosine. How many more slides do we have? Wow, we actually do have a bunch. So, do I have to pick this up tomorrow? Yeah, I have to pick it up tomorrow. I thought I was going to finish today. Anyway, we'll pick up this one tomorrow. Make sure everyone likes, shares, and subscribes, and shows up on time.